for the y-intercept, right? Okay, the problem that we're going to have, do this guys please. The problem that we're going to have is this. All right. If you only did yesterday's note, what's the x value for the y-intercept? What's the x value? 0. The problem was in these equations, we're not going to have the 0th term, right? So we're going to always start with the first term. Okay, so we're going to move around our equation a little bit. Okay, if I have an equation, so we're going to change. Oh, let me just write down the equation. In an arithmetic sequence, each term is added by the same number. Example 4, 6, 8, 10, 12. That's a linear or arithmetic sequence. Okay. The nice thing about these ones, if the equation is set up in this form, it's very easy to find the general term. Okay, and it's very easy to solve equations that are like that. Okay. So what we're going to try and do in the early parts of this unit is we're going to try and find certain types of equations and able to quickly model their certain types of patterns and able to very, very quickly model their equations. We're going to say the difference, the difference is called the constant difference. Common difference, sorry. So again, you have to be going up by the same thing each time. The common difference is also like your constant rate of change, taking the slope. So if we were to graph these, which we're not going to, it would be like your slope for something linear. Okay, so what I want you to find for me in example 1 says find the common difference. I'm going to throw an A, a B, a C, and a D. Okay, where did I stop at? George, since you've passed, I'm going to just come back to you right now. You answered, I don't know, that's what you answered.
Yeah, but I answered that.
Oh, okay. Curtis, what's the difference going to be between those numbers? How did you get that if for someone that can't obviously tell these things? Well, how would you get that? Good. Right. So what you're going to do is, again, 10d, we're going to say equals 3, and you got that from 10 minus 7. Okay. Now please note the difference has to be the same all the way along. Alright, so if when you're doing this, it went 1, 4, 7, 10, 14, all of a sudden it's not common anymore, right? Because the difference all of a sudden changed to 4. I know it's a logical thing to say, but it has to be said. All right. For letter B, all right, Sarah, can you be brave and get your calculator out and tell me what the common difference is between those numbers? By the way, you will need your calculators for this unit. This is very... Stop, stop, stop. It is not times 3. Thank you, Sarah. Did you get 82, Sarah? Okay, so Sarah, try for the class here. Confirm that it's in fact 82.
Times 3, like I said.
Is it 82 now? Is it 82 now? So 96 minus 4, so B should be 82, which is 96 minus 14. But that's a good, my mistake there was a good good comment for you guys. If you saw 14, 96, 178, and 250, it's not a common difference anymore. All right, here's one that you guys should still be able to get. You guys are intelligent grade 11 students, so I'll put it on here for you anyway. What is the common difference, please, David, for this one, please? No, do it again. What's the common difference, please?
It's going down by 2.
Yeah, so we're going to say -2. It's okay to have negative differences. Amy, I hate to do this to you, but you're going to get the trick. What's the common difference, please, for 8, 16, 32, and 64? Times by 2. That's true, that is the pattern, but there is no actual difference. Okay? Because this is nonlinear. Okay, so you can't use what we're doing today, even though there's a pattern on this, and we'll get the more and more increasingly complicated patterns we get. You have to use things other than just linear. Okay, so this only works on, standard linear type equation. Right? Here's our equation. The general term of an arithmetic sequence. Sequence. Ugh. Is going to be Tn equals a plus n minus 1 times d. And think of this like the pain formula and the rain formula and all that sort of stuff, where you're going to need to list all these given information, okay, for things. Okay, since you don't know any of these, I'm going to ask for guessers. Anyone want to guess what d equals in this case? Good. Difference, what we've just been doing. Okay, so this is going to be our common difference. Does somebody want to guess what n represents? Yeah, go ahead. Term number, very good. Just like yesterday, right? No difference. Okay, someone want to guess what Tn equals from yesterday? I want to volunteer, please. No. This is going to be the general term, or the value of the nth term. Okay. And A, what does A equal, please? Nobody knows this one. This is going to be our first term. Now, the question I've never gotten before, because normally I teach this in the first unit and everyone's too afraid to ask questions. Okay, this is normally the third lesson of the year and people are afraid of me still by then. They say, well, Mr. Sadler, if this is a linear system, like it's a linear equation, why is this a funky formula? Why is it not just y equals nd plus a, or something like that? Okay, what's the difference here in this case? A is our first term, okay? Why is it not like the y-intercept, though, for y equals mx plus b? What's the difference?
It's on times by x.
True, yes. True, yes.
Whatever it is.
Well, what is, if a is our first term, remember how yesterday we made this equation, we'd go back to t0, right? This time I'm not making it back to t0, which is nice about this. Okay, so a, this is going to be t1, right? So the starting value here is going to be, again, the first term in your sequence rather than going back to 0, right? So that's why it's not just plain y equals mx plus b. All right, so let's start off with some nice equations here. Maybe we'll stop this, then we'll take a little breather and then move on.